Hey guys, this is Alfonce Murungaru, and I'll be talking to you today about the SSH, the secure shell. It is for my ISA class 4220. The secure shell, it's a popular software-based approach to network security. How this thing works, it's when data is sent by a computer to the network, the secure shell will automatically encrypt the data. When the data reaches its intended recipient, SSH will automatically decrypt the data for it to be readable to the client. This result is what is known as a transparent encryption, where the users can work normally, unaware of how the process is going. SSH uses the modern secure encryption algorithm and is effective enough to be found within usually the new modern day applications. SSH is what it's known as a client server architecture. A server program typically will be installed and run by a system and the admin. It will accept or reject any incoming connections to its host. The user then will run the SSH client programs, typically on other computers, and the user will make requests of the SSH server, such as please log me in, please send me a file, please execute this command. All communications between the clients and the servers are securely encrypted and protected from any modifications usually. The SSH protocols are, the first protocol we have authentication. The authentication protocol, it reliably determines somebody's identity. If you try to log in into an account on a remote computer, SSH will ask for a digital proof of your identity. If you pass the test, you may log in. Otherwise, the secure shell will reject the connection. The number two protocol is encryption. Encryption, it scrambles the data so that it is unintelligible except for the intended recipient. What this will do, this will protect your data as it passes through a network. The last protocol is integrity, which guarantees that the data traveling over a network arrives in the same state unaltered. If a third party captures and modifies your data transit, the secure shell will detect what's going on. SSH makes network connections. A little summary: it makes network connection between computers, which will guarantee that the parties on both ends of the connection are genuine. It also will ensure that any data passing over these connections are unmodified and unread by any eavesdroppers. SSH-based products, some products that use SSH, they implement the SSH protocol. It exists in many Windows, Unix, and Macintosh OS systems. Port forwarding. SSH can increase the security of the other TCP/IP based applications using applications such as Telnet, FTP, and the X Windows system. A technique called, as said previously, port forwarding, also known as tunneling. It will reroute your TCP IP connection to pass through a SSH connection. In a transparent manner, but encrypted on an end-to-end basis. Port forwarding also is good. Note that it can also pass such applications through network firewalls that otherwise would prevent their use. An example: suppose you're logged into a machine away from your work, and you want to get access to the internal news server at your office. The network connected to the internet. The firewalls will block all incoming connection to most ports, particularly port 119, which is the news port. The firewall does allow incoming SSH connections. However, since the SSH protocol is secure, even though that even the system admin trusted, SSH can establish a secure tunnel on an arbitrary local port, let's say port 3000, 3002. And the SSH will establish a secure connection on port 3000 on your local machine to the TCP port 119. So in order to read the news securely, you need to configure your news reading program to connect to port 3002 on your local machine, and the secure tunnel created by the SSH automatically communicate to the news server. The SSH connection sequence, we have the first step is there will be a handshake, which will be encrypted, a cryptographic handshake, which is made by with the server, and the connection between the client and the remote server is encrypted using the symmetric cipher, and the client will then authenticate itself after the first and second process. And then the last step will be where the client and the server can now interact freely over the encrypted connection. The secure shell protects against a variant number of things, such as an eavesdropping of data being transmitted over the network. It also protects against the manipulation of data at intermediate elements through the network. It also protects against spoofing, IP address spoofing to be specific, where when an attack host will pretend to be a trusted host by sending packets with the source address of the trusted host. To also protect against any DNS spoofing. Usually, DNS spoofing will happen over trusted host names and IP addresses. SSH will protect against that. And last but not least, it will also protect against IP source routing over your network. SSH does not protect against an incorrect configuration or usage by the user. So if you're setting up the system and you set it up in the wrong way, SSH will not be able to operate as supposed to operate. It will also protect against a compromised root account, and it will also protect against the insecure home directory. The best practices for the SSH. One, binding to specific address or a non-standard port. If you are, let's say, if you're running SSH on an internal firewalled workstation, this process will not work for a system like that. But if you're running SSH on a firewall or on a machine with two network interfaces, this section does work. This process does work. OpenSSH will bind into every available network address. While being convenient and suitable for most installations, if your machine has two or more interfaces, the trusted and untrusted, you have two interfaces, which is either trusted or untrusted. In this case, you don't need to use the SSH access coming into the untrusted interface. What you need to do, you need to configure your OpenSSH to listen to a specific interface. To have an OpenSSH, you only need to bind to your internal interface. That's the one the IP address 192.168.0.0.1, and this daemon will be listening to any requests incoming through that IP address. Best practice 2, you can use the TCP wrappers. TCP wrappers are used to limit access to the TCP services on your machine. If you haven't if you haven't heard about TCP wrappers, this in the context of the SSH, TCP wrappers will allow you to decide what specific addresses or networks have access to the SSH service. To be able to use the TCP wrappers with SSH, you need to make sure that the Open SSH was built with the TCP wrappers. TCP wrappers are configured by editing your host files. Typically, you will tell the hosts to deny everything, then add entries to the host allow to permit specific hosts access to the specific services. We also have the public key authentication as our last best practice. One of the best ways to tighten the security of your SSH installation is to disable your password authentication and to use the public key authentication instead. Password authentication is a suboptimal because of many reasons, but mostly because people will choose very weak passwords where attackers routinely try and they'll brute force your passwords. Public key authentication is not a silver bullet per se, because similarly people generate passphrases, less keys, or leave SSH agents running where they shouldn't, but in my opinion, is a much better bet if you're using a public key authentication. You can run an RSA authentication, click yes, and then a public key authentication where you have it set up as yes on your system. And that'll be it for my presentation, and those are my references. Thank you.